Hey guys and girls, welcome back to another beautiful video here in our beautiful channel where we go through some C++ examples. I hope you're ready today to just quickly touch on heap because I forgot to mention that in the earlier video. This example is we're gonna be using strings, okay, string, and it's the same thing. Well, I'm just gonna show you how to use pointers for different variables, and it's the same thing. I mean, it's no different. It doesn't really depend on the type of variable. It just depends on the way you write it. So, well, remember the stack. So if we make a string here, name John, and we initialize it to John, well, what happens? This is created in our stack. Remember, because everything we create here statically in our main or anywhere is going to be in the stack. Stack handles things that are not dynamic, meaning that things you cannot delete and make new and create on the go. Okay, these aren't created on the go. These are set in stone for the program. It knows when it translates all this to hardware code, it knows this can change, but there has to exist a string with the identifier name at this point. And these things are created in the stack. So we make a string name. Okay, it knows the variable. It has an address, 0 something, ff something. It's d0. Let's just call it that. And it has the value John now. Okay, it's created in the stack. And there's a lot of spaces in the stack. But what if we do this? What if we do this? We make a double. We make a we make a name string pointer strptr equals null pointer. Okay, and then just like I said in the last one, this is a string ptr. Let's say string ptr with the address something else, 0, and then it has null pointer right now. Okay, but here I just want to touch on some other stuff that we can go through here. What is the heap? Well, the heap would be, we'll make examples of this later, don't worry if it's complicated, but the heap would be if we made something dynamic happen. New string, which you can do anywhere in your program. Whoops. Okay, this you can do anywhere in program. That's why it's called dynamic. This would give us a string in here, okay, and string pointer, which we have here, okay, would hold the address to this. This is just a string. It doesn't have an identifier like John's here, the string name. It's just a value somewhere in the dynamic memory heap. It's called a heap, just because it can just pop things and add things as on the go, just freely. So string, and it has an address. Let's just give it a short address, A02 or something. And it has no identifier. We cannot access this if the pointer was not assigned the address A02. So when we did new, we gave this pointer the address to this new string, just the unidentified string, and so string pointer is directly connected to this. If we were to change string pointer now after we did this, equals, the address to name, address to here. This is the address to it. Well, what happens? What happens? This hasn't been deleted. This is still in the heap. It's still in the memory somewhere, taking up space. But this address is gone forever. It does not exist. There is no way you can access this anymore because it has no name identifier. It was connected directly to string pointer. So string pointer, as soon as this happened here, we got a memory leak. That's what a memory leak is, guys. And that is when these news, every new does not have its own delete. So what we want to do, okay, what we want to do is not let that happen. We just say like this, string ptr equals, let's just print it out so you guys see what's going on. String pointer, dereference it, okay, meaning we don't want to access the address, we want to access the actual string in here, okay. We want to give it a value, so we give it Bob, alright, and then we're going to print out ptr. We can print out the address as well, just so you see the difference. Okay. Okay. So let's see what happens now. And I haven't deleted, so I'm still gonna get a memory leak here. But look here. So the address was printed out and the value to Bob. So what happens is in here we have Bob now. And we are back to having this address here. The value of it is the address to this new identified string. So what we have to do is we have to delete strptr. And why do we have to do that? Well, if we don't, this is always going to be in the memory until you turn your computer off, which means it's a memory leak. If we delete it at the end of the program, okay, knowing that, or at any time you don't want string pointer to point to this thing here, you need to delete it. You need to make sure it's gone. So we won't delete it at the end of the program. We're going to do this. We're going to delete strptr. Okay, making sure this is gone now forever. Okay, so there is no memory in the heap. It has been deallocated. This is called memory or allocation. Okay, this is deallocation. So you're taking it away. And once you do that, this string pointer has a undefined, or it still has A02, but it will have an error if you try to access it. So what you want to do is either directly make it a null pointer again after that. If you are not sure that you're going to use it, you definitely want to just make it a null pointer again, or you give it a different value. So here in this case we're going to give it name. Alright, we're going to give it the address to name. So John, this was the address to John. We have a new value here. The heap is empty. The stack, you know, it can point to things in the stack and the heap. But every time you make a new, you allocate memory, the heap is the one that takes care of that. Okay, the pointer itself has an identifier, so it's always in the stack. Okay, but what it's pointing to, new allocated memory will always be in the heap. So let's see what happens here after all these steps of stuffs. Okay, let's do this. Let's see what happens. Well, we get Bob and then we get John. See? And we don't get a memory leak because we deallocated that memory. Okay, so this is really important to know. Okay, and another thing is if you're trying to delete something that is static, you're gonna get a big ass error. So don't do that. Just make sure you delete things that are non-static, things in the heap. Okay, things that you know you have created with a new keyword, like a new keyword you want to delete. If you try to delete something static, that won't work. That's what your computer takes care of itself. Your computer takes care of all of this stuff. C++ takes care of all of this stuff that you create statically, or well, yeah, in the stack basically, not static but in the stack. So, and it even takes care of your pointer itself because it has to clear this pointer out as well, right? It's taking some memory itself. But what it points to, you need to take care of if it's dynamic. Okay? So let's just call it dynamic allocation. And this is one step up for us because now we can start talking about dynamic arrays and makes a lot of intricate examples on that. But yeah, I hope you learned something. Remember, don't delete things that are in the stack. Delete things that are in the heap. And make sure you don't get any memory leaks. And be happy in life. Alright, so thanks for watching. I hope you learned something today, and I'll see you in the next video.